Hey, what's going on, folks? It's Mike here, and welcome back to the D Programming Language series. In today's lesson, we are going to be looking at Variadic templates in the D Programming Language. Now, Variadic templates are also known as sometimes sequence parameters, or there might be other names in different languages. But I'm going to go ahead and show you Variadic templates in D. This is also the name that I've learned about in other languages like C++. But we're going to see they're quite a powerful feature. So with that said, let's go ahead and go to the dlang.org website. And I'm actually going to take us this time to documentation and then articles. So we'll find here on the left-hand side the Variadic templates, and then something that's also sort of related that we might check out later, but compile time sequences. So you can kind of read these in order, generally speaking. But if we're just looking at, if I scroll down here again to the Variadic templates, this is going to teach us about what Variadic templates are. So let's go ahead and visit the problem here. And this is really well stated in the article here, where basically I want to be able to print out some number of arguments here. And I don't know if I'm going to have a print function with 3 or 4 or 5 or 20 or maybe 100 different arguments here, but I want to really avoid having to write out all those functions. So in C++, there are solutions for this. In fact, if you're coming from the C++ background, like if you've seen my other series, we have Variadic templates available here. And interestingly, the way that we used to use them by doing metaprogramming before, we had that ability to declare a sort of unlimited number of arguments, is to, well, either resort to enumerating them out, again, as shown here, with 1 argument, 2 arguments, 3 arguments more. Well, in C++, they're between the angular brackets here. Or you could rely on library solutions like var args, as you might have seen in the C library. Again, those can be okay. You maybe lack some type information, and there's different things to wrestle with. But in D, we make things relatively easy. So I'm going to kind of skip over the C++ stuff, but basically they added the same thing that D had with the 3 dots after the template argument. And let's look at the D solution here. So again, we're going to ignore like the library solution. We don't really want to do that here with var args. But again, if you want to use C code or do things in a C compatible way for whatever reason, you have that available as always. But let's go ahead and scroll down here a little bit. Now we don't really need to do the 2 overloads here and have a base case, which again is something that you maybe learned in C++. But instead what we could get away with is basically just print a template parameter here and then have the ... here. And then whatever this A is here, sometimes this is just abbreviated for args. In fact, let me zoom in on it for you just so you can see it nice and clear. Basically we could treat that like a array type, okay, some sort of fixed sized sequence here. Okay, so they're maybe we could think of them as arrays or tuples. I mean, their size is known, their size is fixed, right? This is at compile time that we have this in our template parameter list, this Variadic template here. Okay, so that's the basic idea. So you get the advantages of, if you know things like .length and so on, we can actually inspect how many of these values there are and do things at compile time. Because again, templates, we think compile time. Okay, so that's one way to look at it. We also have the for each or static for each, which again, we can do things at compile time, which is super neat, where we can actually write out the line here. So let's just go ahead and play around with this a little bit. Let's go ahead and just start with this. Whoops, there we go. My Vim's going crazy. Let's just go ahead and write this print function here, just so we can understand how it works. Then maybe we'll play with it. I'm going to label this args. Sometimes folks do that. You could use T. You'll also see that in the documentation, but args is decent for what we're doing here. And then we could actually just write line. Let's see what happens if we do something like this here. Okay, and then what I'm going to do here is print. I don't know. Let's see. We could have multiple values here, 7, 6, 5, something like that. And then we, of course, need to pass in our args. Let's actually see what happens here when we use this. So, for example, and let's see, like, is this the right way to call it? I mean, we have this args here, but we have the Variadic template, and this is the type of thing that we're trying to pass in here. So let's see if we just try to make a call as follows here. And we're going to get a message here that says error sequence args is used as a type here. So that's for the sort of like sequence type. Error template instance main.print yada 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 errors instantiating. Okay, so how do we actually make the function call here? Well, it's actually quite nice here because again, we don't need the you'd be tempted to say, well, what goes inside of here in the parentheses here? So basically what I'm going to show you is nice again in D is all we really need is print, and let's go ahead and put 1, 5, 6, 7 or whatever here. And that's going to give us 1, 5, 6, and 7, these individual values here. So let's go ahead and print, or rather play around with this print function here. And let's say that we wanted to pass in a series of things like int and string here. Now, would this still work here? What would this do? Okay, cannot pass type int as a function argument, cannot pass in a type string as a function argument. Okay, so there's a few interesting things going on that we want to understand here. So let me get rid of this example here. And let's try to break this up, because I'm actually not sure if this is a sequence here. I'm just saying print 1, 5, 6, and 7 here. And it's doing this sort of interesting concatenation here of 1, 5, 6, and 7. So what if I broke this up by putting in like B here or something? Let's see what would happen here. I still get 1, 5, B, 6, 7 here. Okay, interesting. So I'm basically just taking in this sort of sequence here and packing it together, right? So again, it's not quite an array to think of it like this way, but it's an array-like thing here. Okay, so let's try to play around with it a little bit with maybe some of these primitives that we have here. So for instance, let's do for each of the arguments here. I'm just going to mimic this example here. I'll put in a t here so we can play around with it. And now I am able to treat these as individual values, right? I'm saying for each of these, because they are comma separated, but if I'm just writing out the args here, I think D is just like smashing them together there. Okay, so that's the basic idea here. Now, again, we can get into interesting things like making this a static for each here. So I could go ahead and run this here. And I might even be able to get away with basically doing what's known as a pragma here, message, and then let's write out T here. And let's see here. So I'm trying to do this at compile time. Let's see what error message did I get here. It's saying, okay, all the parameters, 0 cannot be read at compile time, 1 cannot be, 2 cannot be, 3, 4, etc. Cannot be evaluated at compile time. So how do I get around that? Because I thought I was able to do, something interesting here with printing things out. So in thinking about this, again, we have to sort of keep things a little bit organized here and what's actually going on. So here's our arguments, which would be evaluated at runtime. And what we really want to do when we're doing something that's static for each is this is at compile time here. So again, if I'm trying to look through these arguments at compile time and write them out here, that's why it's complaining here. So it just says it cannot be read at compile time. We don't know what the value is, all these different things here. So what we really want to be looking at here or iterating through is the actual args here. Okay, so let's go ahead and try that here. I'm going to go ahead and run this. And we're going to see a little bit of a weird behavior with DMD because I think it's running it or compiling it twice or caching it. So I do see int, char, int, and then I see int, char, int here. So let's actually compile this as just a program here. And again, we'll see that while we're just compiling this, this is returning us the types here. So we can do some interesting things where we're like iterating through the types here and so on. So anyways, this is with the template arguments, making them variadic, which again is very interesting and quite powerful if you want to do stuff at compile time with multiple arguments. Again, you can start to do things recursively, for instance, and actually starting to, well, solve a lot of problems at compile time beyond that just printing out the actual type here. So anyways, I just thought this would be interesting to kind of show off what the ... is here and where you might use it for something exactly like a print function or a write line function, which you might be taking in, again, any number of different arguments here and trying to do something with them. Again, we could do things at compile time. In fact, I'll just go ahead and I'm going to just comment this example out here. I'll call this the compile time example because it's a little bit more pragmatic for us right now to just have a function here. Again, that's just doing stuff at runtime here. And for any number of our arguments that we provide to this function, just to print them out here. So let's go ahead and just run this one here. So you can see the actual values that we're writing out here. And then if you want to get into compile time stuff, again, you can think about these static for each and so on functions, which again are kind of the point, another enabling point of having these variadic templates so you can compute something recursively, right? Because you can imagine trimming this list by 1, for instance. Anyways, I'll leave it at that and just leave you with a pointer here if you want to think about that a little bit more, that you could do things like, for instance, look from, the first element to the end. And again, if you call this recursively in your template, you're effectively chopping off the first item here. So if some of you have done some like functional programming in Scheme or something, this is going to be kind of familiar for how you can iterate through lists and these types of things. So anyways, folks, I hope that was useful for you and you enjoyed it. As always, you can track your progress on my website here. Here's the D programming language site. It's free to enroll. It's the same lessons that you're watching here in a distraction-free environment, and you can track your progress if you find that useful. So anyways, folks, hopefully you enjoyed that. And I'd be curious to hear your comments below about Variadic templates, different use cases, if you've done something cool, recursive, or particularly with D's compile time function execution engine. I think that would be really cool to share with the community. Anyways, folks, thank you as always for your time and attention, and I'll look forward to seeing you in the next one.